That has a hole in it.
That has a hole right here.
Oh, that's right. And I was gonna clean it, but I was like, when I woke up.
Okay, so guys, I wanted to talk to you guys about, like especially these first three here. When we see fractions, so we freak out, we forget how to do these. So notice the different directions. So it says simplify, solve for x. So these again are similar to ones on your review, similar to ones that are going to be on your exam. But it's just ones I got lots of questions about already as of yesterday. What do we do for number one for simplifying here?
Times 4.
We do not want to multiply by 4.
Oh.
Because we're not solving here. So we're not undoing. We're doing what it says to do.
Divide by 4.
Divide by 4. Very good. So that's exactly why that's on there. So we should divide into these by 4.
He's so mean.
And we divide each of those by 4, so we end up with 3x minus 4. So we're simplifying here and just dividing the 4 by each of those.
Who was it during that?
I thought he was beatboxing. I thought he was beatboxing for a second.
Sure. Okay, so just making sure, and like I said, that's why we talked about this one, because you guys aren't the only one who thinks that. So that's, I mean, I was kind of anticipating that being the case. So if it says to simplify, there's nothing to multiply by 4 by because there's not like another side of the equal sign. However, in number 2, we want to solve. So now it says solve. How are we going to go about setting this one up? Yeah, we can do the cross multiply. So when I have a fraction equaling a fraction, we can cross multiply. Oops, well, I guess I just do it this way. So I'm going to distribute this in. And then I'm able to solve. And again, I should only get one answer for this. Just the cross multiplying and solving, we're finding the x that works for this problem. Why did that going around? That's what Esther just came in to ask me about. 8 minus 7.
Yeah. It's like a little bit. My thumbnail died.
Oh, your nail polish.
It's my real nail, so it's not.
Sad thing in about these chickens, you know, getting sent to the vet.
Oh, yeah.
They're so mean to them.
I know, I can't handle it. I can't handle knowing what happens with my food.
Yeah, but I'll still eat one.
I know. I lost a toenail for this, so.
Me too.
It was my real nail though, so
It was my real
like,
toenail too.
it's not like I'm bleeding.
My brother shut all the doors in the house because he thought we were going to get TV. Don't know why you need to shut all the doors in the house.
Okay. So, and then in number 3, they want us to solve for x, but notice there's a whole bunch of different variables in this problem. We still want to solve for x. That means we just want to isolate the x. So we're going to undo what's happening to x here. So what do you guys want to undo first in this case?
5 and 5.
Yeah, let's get rid of that 5. So again, 2 different problems here. Now we can multiply each side by 5.
There we go.
And so I'm just going to call that 5m. Again, I want to get my x alone. What are you going to do next?
Add y.
Add y. And then to get x alone, divide by 2. Now that doesn't divide nicely, so I would just leave it as a fraction. That's fine. All right, the next couple are good to talk about because they're the absolute value equations and inequalities. It's really easy to forget about this piece that if we're solving absolute value, that's where we have to remember there could be up to 2 answers, or there could be 2 answers, or there could even be a situation where we have to solve and set up an inequality, like a compound inequality for this. So when you're solving absolute values, this might be a good note card thing to put down. You have to remember both a positive and negative version. So we're going to set up two equations here. So the normal one, 3x minus 5 equals 19. But then there's also the second one, that's 3x minus 5 equals a negative 19. This is where I kind of covered up what was in there with the heart and said, like, what could be underneath there? That's what's going on here. So we have to solve each of these because each of these are valid solutions. So x is 8, but also we have to solve the other one. And then so there's 14, negative 14 thirds is fine. We call that negative 2.6 repeating, 2.67. So you don't want to forget about that second answer. Same thing for number 5. But on number 5, we have to remember that on that negative one, we also have to do what? Flip that inequality. So we're going to set up the two equations in this case, but again, on the negative one, we're going to flip the inequality. So we flip it on this one. So don't forget about that. So you flip it and make it negative. X is greater than 7. And x is less than negative 11. And so then we can put this on our number line to graph our solution. Remember, with a number line, we have either open circles or closed circles, depending on the type of inequality it is. So since these are strictly greater than or less than, we do open circles. And then it's greater than 7, but less than negative 11, so it's going to go smaller. So this is an or inequality. It's one or the other. It can't be both things. It has to be greater than 7, but less than negative 11. So all of these types of problems, again, are ones that you guys were asking me about, which is totally fine that you guys ask me questions. It's just I want to make sure that you guys feel comfortable with kind of these frequently missed ones, like things that are easy to forget about them. So anything that's helpful to you guys to put on your note card, including examples, is fine with me. So that was chapter 1. There was quite a bit in chapter 1. Then in chapter 2, we got into graphing lines, graphing inequalities, writing equations, graphing absolute values, so a whole lot in there. Sorry, these graphs are really tiny. To write with a really tiny pencil. So now I want to mention number 6, you guys, because graphing by intercepts is not typically everyone's favorite way to graph. So it says find the intercepts and then graph. So I want to remind you guys how to find the intercepts of a graph. Those are the x and y intercepts. It's actually kind of an easy way to graph. You only need 2 points, but understanding the intercepts is a helpful thing. So knowing where those are and how to find them. So remember the x-intercept's on the x-axis. So what do I know about points on the x-axis? There's something in common with all the points on the x-axis. know about all the points on this line?
The second number is 0.
The second number is 0. So the y is always 0. So I already know the second half of this should be 0. So that means I can put 0 in for y up here. Interesting thing though is that'll cancel that part out, so you can almost think about it as covering that up, that 6y part, so it's going to be 3x equals 12. So x is going to be 4. So 4, 0 is my first point, my intercept. And the completely opposite thing happens for the y-intercept, where now x is 0. So the first value is 0. So I can put 0 in for the x. That's going to cancel. And then I can solve this. I can divide by the -6. The y is -2. So 2 points is enough to draw our line. So I can graph by intercepts. I can find the intercepts. Now you could have graphed this using slope-intercept form, y equals mx plus b. So that's probably your more preferred method, but they do ask you to find some intercepts, I think, on the review as well. So in example 7, don't forget about with graphing inequalities. This is where we have to graph and shade because of the inequality. So I'm going to still get it in slope-intercept form on this case, because it doesn't tell me I have to use intercepts or anything like that. But that negative y is makes it a little bit tougher problem. I have to divide by -1, but that also means I have to flip my inequality because I divided by a -1. So I have to flip the inequality to face the other direction. So now I'm going to go down to -7 and then go up 2/1, graph my line. It's going to be a dotted line. And then we have to decide where to shade. So you can think of it as y is less than this. I should go under it. Over here, you can think of 0 is not bigger than 7, so 0, 0 doesn't work. So I will end up shading down here. So if you check 0, 0, it won't work. Remember, we have to shade a whole section of the graph. Start coming back to you now?
No.
Oh, God. Kidding.
This was like 3 weeks ago.
Right.
Was it? Okay, maybe a little more.
This year has strangely felt fast and slow all at the same time. I don't know how that works, but it does.
Well, it's weird to think that like you'll be done with like the classes that you only have for 1 quarter.
Yeah. Yeah, it's weird. Okay, so then we have perpendicular versus parallel. So writing equations of lines that are either parallel or perpendicular. Now remember, parallel lines have the same slope, so that might be worth listing up here. Whereas perpendicular, what do I do with their slope? Perpendicular lines. You do the reciprocal and you change the sign as well. So this one's m is 3. Our new m is going to be what? -1/3. Very good. That's going to be the slope we're going to use for our line that's going to be perpendicular to that line. So I'm going to use this M and this X and Y. I don't want to use their B at all. So this is the information I'm using. So putting that into Y equals MX plus B. Negative 1/3 of 9 is a negative 3. We find out B is 3. So there's our new equation. That would be perpendicular to that one, but would go through 9, 0. Now, had it been parallel, we just use the same slope. All right, so if you want to flip it over then, and you can't throw parts around. Oh my goodness.
What are you doing?
I know. Neat piece of information.
Let's go.
Just throw. What's up? So parallel, then you would keep the same slope. So you could do the same exact example, but you would keep the M the same. So it'd be a different answer. You want to see parallel?
Yeah.
Okay, so I'll write it right up here. So if I asked you to do the same question with a parallel line, we'd use the slope of 3. So we'd use their slope, and we'd use this point. We're going to use that as well.
Does it? Examiner your packet. I wrote it. It looks like we're in.
No, it doesn't.
So we multiply the 9 times 3. So I'd end up having to move that 27 over. So B would be a negative 27. So this would be the line that's parallel to that one. So those lines would be parallel. Or sorry, parallel. These two would be parallel. Sorry.
What are you doing?
All right, now if you're ready to flip the page over. Talking about graphing absolute value, I'm guessing this is one thing that might be a little rusty on if you haven't reviewed that for a while. I was still in chapter 2. This is when we played online with Desmos and we moved those V-shaped graphs, and they moved and they animated themselves when we moved the H and K.
That's so
So hypnotizing. Well, hopefully you learned something from that. Since clearly you guys all remember this so vividly. So if you guys recall, the H is how you move the graph left or right, but it does the opposite of what we expect. So H moves our graph left or right, but if it's positive, it moves it left, negative, right. So it does the opposite. K moves our graph up and down, but that one works the same way it is.
Why did they have to flip it?
Make it tough on your life.
These math guys.
And then the A is the slope on the right side. And then we just do a mirror image. So we're going to first set where our vertex is, and then we'll work on the slope and cause it, make our V shape. So the 4 looks positive. That actually means we're going to go left 4, and then down 5. Left 4 and down 5. So my coordinate point left 4, down 5. From there, I'm going to do my slope, which is my A value, which is this 2. So 2 over 1 is going to be my slope on the right side of my graph. So from here, I'm going to go up 2 and over 1, up 2 and over 1. So that's the first half of my V. And then there's going to be a mirror image on the other side. So I just have to reverse this. Sorry, those graphs are really tiny. So this should be a relatively skinny V because of that slope of 2. So at the vertex, you got to go in the other direction. Yeah, you don't want to keep going the one same way. At the vertex, you change direction. That's probably a good one to review. So there are a few more review problems on your exam review packet, and I intentionally picked problems that weren't on your review packet. They're similar to them. I picked different ones so that you guys could practice those different problems. Now, the last couple chapters, I didn't really know what to put on there because I thought you guys did pretty well with the last few chapters. I wanted to review vertical versus horizontal lines, and then also the system of 3 equations, but anything else you guys want to add to that, we can, or if we come up with something else. Do you guys remember what kind of line is x equals 6? Yep, so vertical line. So x equals 6, I'm going to go over to 6 and draw a vertical line there. So remember, x equals is a vertical line, y equals would be a flat line. And then this one I need to get into slope-intercept form. And then I can do my slope from there. And then the 2 lines cross, and that's where my solution would be. So in this case, that happens to be at 6, 0.
You have that stupid thing stuck in your head. Mommy is there back.
It's like in my head too.
No, she was singing Years by Justin
And she
Timberlake.
said
She was singing the words wrong, and now the wrong words are circling my head.
It's not the wrong word.
He goes, Mommy, is there a packet game?
I don't think so. No, it's not.
Yes, it is. Play it then.
I did yesterday, and we looked at the lyrics, and you were wrong.
What is it?
Years?
Mommy, is there a packet?
That's what it's like.
Yes.
For 11.
Yeah. It's up to you how you want to start. So let's talk about number 11 then, if you guys are ready. I was just trying to make sure everyone's good on this. Not quite yet?
No.
Big thing with 11, as you guys start on those, is you have to decide which variable you want to get rid of first. Like, which one looks easiest to eliminate? Do you have a preference? I'd say Y or Z. Probably lean towards Z, but we have a preference.
I started off.
So whatever we decide, we have to decide to do both equations using the same one. So what do we want to do, Z or Y? We need to vote?
Yes.
Okay, vote. The Z's. 1, 2,
I want to go
no,
against Kinsey.
3, 4, 5. Okay. Y's. 1, 2, 3, 4, 5, 6, 7. Okay, Y's have it. All right. So we're going to add the Y's together. So the first 2, I can just add these 2 together, right? Because that'll cancel out the Y's. So I'm going to add the Y's here, or add everything. So 2x and 3x is 5x. The Y's will cancel. This will be 1z, 1z. And then 7 and 5, 15 is 22. So I got rid of Y. Now, once I decide to get rid of Y, I have to choose to get rid of Y in the other equation too. So now we have to use this bottom equation to also get rid of y. Which equation looks easiest to use? The top one. What do you have to do with the top one? So I'm going to take this one and this one, but I'm going to multiply the top one by 4. The reason for that is because I already have a negative 4y, so I want a positive 4y up here. So I'm going to multiply this one by 4. So this is going to be 8x, 4y, a negative 4z, and then 28. So I'm adding these two together now. So now I have two equations with two unknowns, which is what I want. So I have two unknowns here, x and z, x and z. So again, this line came from multiplying this one by 4. Is everyone okay with that? All right, so now I have these two. I want to combine them now. So I have 9x and 5x, that's no good. Negative 3z and 1z.
There you go.
Yep. If this can get multiplied by 3, then it would cancel here. I'm going to put this one right underneath. So now the z's cancel. Oops, 24. X. 96. So x ends up being 4. Now, once I know x, I have to work my way backwards. So don't go all the way back to the start. Go back one step. Go back to where you only have the two variables in the problem. So putting x back in here. So z ends up being 2. Now that I know x and z, then I can put those back in to find our y. And I'm just using the top equation. Right. So I have my x, y, and z. So was there anything else that you guys are running into on your review that you want more practice of? Does that help clear up some of the things that you did struggle with? Okay. All right, I'll give you guys some more time to work then. We have a big chunk of time here again. Again, continue to work on your note card. Tomorrow is our last day together. We don't see each other at all on Thursday unless you choose to come see me or you're stuck in the study hall and then they send you over by me. So know that you can come see me during those free periods if needed and if you guys need help, okay? So the review should be close to done tomorrow, if not all the way done on Friday.